Hello everyone. Welcome back to another daily LeetCode challenge. Today's problem is LeetCode 2092. Find all people with secret. You are given an integer n, which represents the total number of people, numbered from 0 to n-1. You are also given a two-dimensional array called meetings. Each entry in meetings is of the form x, y, time, meaning person X and person Y have a meeting at a specific time. A person can attend multiple meetings at the same time. You are also given an integer called first person. Initially, person 0 has a secret, and they share the secret with first person at time 0. From that point on, the secret spreads during meetings. If either person in a meeting has the secret at the meeting time, the secret is shared with the other person. This sharing is instantaneous. That means if someone learns the secret during a meeting at a given time, they can immediately pass it along in other meetings happening at the same time. Your task is to return a list of all the people who know the secret after all meetings have taken place. The order of the result does not matter. This problem requires careful handling of time-based interactions. Let's walk through an example next to see how the secret spreads over time. Now let's understand this problem better by walking through the examples. Example 1, we are given n equals 6. Meetings equals 1, 2, 5, 2, 3, 8, 1, 5, 10. First person equals 1. At time 0, person 0 already has the secret and immediately shares it with person 1. So initially, people 0 and 1 know the secret. At time 5, there is a meeting between person 1 and person 2. Since person 1 knows the secret at that time, person 2 learns the secret. Now people 0, 1, and 2 know the secret. At time 8, person 2 meets person 3. Person 2 already knows the secret, so person 3 receives it. Now people 0, 1, 2, and 3 know the secret. At time 10, person 1 meets person 5. Again, person 1 has the secret, so person 5 learns it. At the end, people 0, 1, 2, 3, and 5 know the secret, so the output is 0, 1, 2, 3, 5. Example 2. Here we have 4 people, numbered from 0 to 3. The meetings are 3 meets 1 at time 3, 1 meets 2 at time 2, 0 meets 3 at time 3. The first person is 3. At time 0, person 0 shares the secret with person 3. So initially, people 0 and 3 know the secret. At time 2, person 1 meets person 2. Neither of them knows the secret yet, so nothing happens. At time 3, 2 meetings happen. Person 3 meets person 1, and person 0 meets person 3. Person 3 already knows the secret, so person 1 learns it. Person 0 already has the secret, so that meeting changes nothing. At the end, people 0, 1, and 3 know the secret. That is why the output is 0, 1, 3. Example 3. Now we have 5 people, numbered from 0 to 4. The meetings are 1 meets 2 at time 1, 2 meets 3 at time 1, 3 meets 4 at time 2. The first person is 1. At time 0, person 0 shares the secret with person 1, so people 0 and 1 know the secret. At time 1, 2 meetings happen at the same time. Person 1 meets person 2 meets person 3. Person 1 shares the secret with person 2. And very importantly, because sharing is instantaneous, person 2 can immediately share the secret with person 3 in the same time frame. So after time 1, people 0, 1, 2, and 3 know the secret. At time 2, person 3 meets person 4 and shares the secret. By the end, everyone from 0 to 4 knows the secret. That is why the output is 0, 1, 2, 3, 4. These examples highlight the key idea of the problem. Meetings at the same time can chain the secret instantly, and handling time correctly is crucial. Next, let's move on to the solution approach and see how we implement this efficiently. Now let's break down the solution and understand exactly how it works. This problem is all about tracking who knows the secret over time, and the key challenge is handling meetings that happen at the same time, because secrets can spread instantly within that time frame. To solve this efficiently, we use a disjoint set union, also known as union find, high-level idea. We group people together when they meet. If anyone in a group knows the secret, then everyone in that group knows it. However, we must be very careful. Connections created at one time must not incorrectly carry over to the next time if the secret was not involved. That's why we process meetings time by time. Step 1. Union find setup. We start by initializing a parent array where each person is their own parent. The find function helps us find the representative of a group, using path compression for efficiency. The union function simply connects two people into the same group. Step 2. Sort meetings by time. We sort all meetings by their timestamp. This is extremely important because the secret spreads forward in time, never backward. Step 3. Initial secret sharing. At time 0, person 0 shares the secret with first person. So we immediately union person 0 and first person. This ensures both belong to the same group from the beginning. Step 4. Process meetings grouped by time. We now iterate through the meetings, one time block at a time. For each group of meetings with the same timestamp, we union all pairs of people who meet at that time. At the same time, we record all people involved in these meetings. This temporarily connects everyone who met at that moment. Step 5. Validate secret propagation. After processing all meetings at a given time, we check which group contains person 0. Only people connected to person 0 should keep their connections. Anyone who is not connected to person 0 must be reset. So for every involved person, if they are not in the same component as person 0, we reset their parent to themselves. This step is crucial. It prevents the secret from spreading through meetings where no one actually knew the secret. Step 6. Final result. At the end, we simply collect all people whose root is the same as person 0. These are exactly the people who know the secret after all meetings. All right, now let's hit run code. Perfect. All the sample test cases are passing without any issues. Now for the real moment, submit. And there it is. Accepted. All test cases passed successfully. That confirms our union find with time-based grouping approach is working exactly as expected. If this explanation helped you understand the problem, make sure to like the video, subscribe for more daily LeetCode solutions, and drop a comment if you'd like a breakdown of a different approach or optimization. Thanks for watching, and I'll see you in the next problem walkthrough.